the last, another very common one that I'm sure Ron in particular is very familiar with as a statistician is correlation. So correlation measures essentially the linear relationship between the objects. It tells us if as attribute or as object P if object P and Q move together is kind of the way to think about it. So what we do is we standardize each of the object's attributes, and then we take their dot product, and it gives us a value between 1 and -1. So it's not exactly a standard similarity measurement that describes, though we can square it, and then it becomes between 0 and 1 and becomes a standard similarity measurement. That's sometimes called the coefficient of determination. R is the coefficient of determination. R squared is the correlation. I don't remember my statistics classes well enough. I apologize. The two tend to get used in data science very interchangeably. So here, for those of you who haven't had that much statistics or who don't remember, is a visual example of our correlations. So when correlation is -1, which is the highest possible value or the lowest possible value, we have a very linear relationship. As one object goes up, the other comes down, whatever up and down happen to mean in this context. And whereas a correlation of 1, we have the objects are going up together or coming down together. And as we get to correlations that are closer to 0, we can see that this data clearly has very little relationship. Whereas we get closer to 1 and -1, we see a sharper and sharper linear relationship between the two. Correlation is often used as a metric is one of the metrics that we use to evaluate regression models. So we'll talk about it more in that context. But I just wanted to make sure we introduced it so people had heard the word. If you haven't had if you haven't had much of a statistics background, or it's been a while.